Now let's have a look at the main parts of such a predictive maintenance application, which you would realize with the acquisition and processing of big data. First, you somehow have to acquire the data. You would acquire the data by equipping your machine, your plant, your vehicle with sensors. Sensors which somehow register the physical situation in your machine, in your plant, in your vehicle. For example, by monitoring the temperature in a machine, or the gasoline usage in a vehicle, or some vibration could be important, for example. And of course, you would not do that only for one machine or one vehicle. You would do it over the entire fleet of vehicles. The entire fleet, for example, if you work in a postal delivery company, then you would try to do this analysis. You would equip all your vehicles with these sensors to get an overall view of the, so to say, health status of your fleet. But the first part in the data acquisition, you do not conclude to any health status. You first monitor the condition of your machines. First part, data acquisition. Then there comes the second part, the data storage. Depending on the value of your data you want to acquire with the sensors, it might be useful if you transfer the data via a mobile network. If these data are of high value, the acquired data, maybe you need to make a real-time decision, then the data are of high value, and then you would transfer the data quite early via a mobile network. If it's enough to analyze the data later on, if real-time processing is not that important, you could transfer the data, for example, if you are in the Wi-Fi network in your depot. And finally, in both ways, you somehow persist the data in a preferably centralized database. Data storage, second point. The third part is the data analysis. And in the data analysis, you could imagine that the goal for data analysis is to find a proper frequency for doing the maintenance. Like I showed you in the slide before, the proper maintenance might be here in this area B, where you do the maintenance not too often and not with a low frequency, but in an optimized frequency. So let's say every quarter or so. And the data analysis should lead to a good value for these maintenance activities. And these maintenance activities are not only done by statistics acquired by the sensors, but also by specifications of the machines, which might come from the manufacturer, the driven kilometers, then the statistics maybe with defects happening in some ranges of kilometers, or some special types of machines, for example. Oh, that you know, in a special type of machine, there's a certain defect happening at kilometer 100,000, for example. Then you would do these maintenance activities upfront before the defect actually happens and before the defects causes you loss in production, loss in post-delivery activities, for example. The visualization part is not that important in this application. It's more important to do this planning of the optimal frequency for each vehicle. The visualization could be done in a kind of plan for the maintenance, or maybe some simple statistics, but it's not the main part here, which is to mention. And the application, as you might see from the explanations, is actually done in the real world by UPS. UPS, the postal delivery company. UPS monitors the entire fleet with such kind of sensors, and UPS tries to optimize the maintenance activities with the help of these monitored data, analyzed data, and conclusions from these analyses.